Comparative embryology. So, the word comparative means is related to comparing, and embryology is the study of embryos. So, this presentation was prepared by Cyrus and Obadiah. So, this is Obadiah presenting on my channel. I have rights to present this. Now, this is a branch. This comparative embryology is the study that involves comparing embryos of different organisms. Yes, highlighting the ancestry, and that is it. So it may focus on cleavage and tissue differentiation and the evolutionary connections between organisms. So basically, comparing embryos, I think you would get that. I think that thing will ring into your mind if I speak comparative embryology, comparing embryos. You've seen the things that man can, that embryos, the that embryos of man, an embryo of a man resembles that of the fish at a certain stage. So those things we're going to look at them. We're going to dive deeper into them. Those want to get to know more about it and understand it. Get the gist of the matter. Need to watch this video. We are going to watch this video. I don't want you to get off. Don't switch off. We're going to get everything that we need to know about this. Now, we've got the definition. Now we need to understand the similarities of the embryos. So in comparative embryology, there is comparing of embryos. So at early stages, embryos of vertebrates, fish, amphibians, birds, mammals look very similar. I think you can see that they look a little bit similar. This is according to Haeckel. According to Haeckel, you see that they are very similar right there. Very, very similar. At a certain stage, they are very similar. They have that post annual tail. They have that tail. I think you can see the tails. The tails. They have the tails according to Haeckel, and they have those pharyngeal gill slits. The gills right there. See those gills, the ones that I'm marking. Those gills. So they're key. It's very key to notice that they are. Then the common features, like I mentioned, are the pharyngeal gill slits, the tails. So you saw the body segmented, notochord inside. So pharyngeal, like I told you earlier, that the gills are found right there. I think you can see the gills. There's a bulgy head, there's a tail, and as you can see, the fish. If you can look at the fish right there, stages are going like this, moving down, moving down. So Haeckel was saying that ontogeny recapitulates phylogeny. So ontogeny would be the development of an organism from the embryonic stage, from the egg up to the adult form. You get what I'm saying? That is ontogeny. While phylogeny would be the evolutionary history of an organism, how it evolved from its ancestors. So he proposed that we came from a common ancestor, and so as we are growing or developing from the egg, we repeat the same stages that we went through while we were evolving. So that was his statement. And from that perspective, we would realize that we could take or understand that this fish, the salamander that we see right there, the tortoise, the chicks, the hog, the calf, the rabbit, the humans, all have a common ancestor. And we repeat these stages as we are developing from our mother's wombs. We repeat the stages: the egg, the what, the embryo develops. Then the embryo goes through stages that are kind of similar. That is according to his theory that we're going to look at in detail. So, so that is it. Phylogeny, recapitulates, ontogeny. We've looked at it. But it has limitations and there are misconceptions that you need to know. Adult features of ancestors are not really seen in the embryos, because we want to compare embryos with embryos, not embryos with adults. So there is no way that an embryo of an organism right now will resemble an adult form of its ancestor. So if you're comparing embryos, compare embryos. So that is a limitation for him. That speculation that we came from a common ancestor. that we repeat the stages we went through as we were evolving during our during our ontogeny. So that is wrong. Then species skip developmental steps. We have seen certain species like the sea urchin skips developmental stages. We compare it to its related or organism to which it is close to. They pass through larval stages and whatever, but for it, it develops directly and into an adult sea urchin from the first stage, and then goes directly to the adult stage. Then we have developmental traits that do not proceed at the same time. They don't proceed at the same rate. In this, I mean that certain organisms don't develop at the same rate. If you compare the embryo of a chick and a man, certain features will not develop at the same time. So if you're comparing, certain time you reach and they'll be a little bit different. It's a 2 day or a 2 month old chick is not the same as a 2 month old embryo of a man. So the embryos of the chick develop faster than that of a man. Embryos of different species are not identical, but rather they share similar stages. So how over exaggerated is thing? The relevance of this is that it proves evolution, connects patterns of common ancestors. There is can be used in comparison during classification. Yeah, classification. Yeah, we can use it to categorize certain organisms that have similar stages in the embryos into particular taxonomic groups. Then it propels the understanding of developmental biology, the understanding of organs, how organs come up, how they develop. So thank you for listening. I want you to watch the next video. Yo, if you want to know more, that's it. I'm out.